Hello my dear students, my name is Lakshmi Narayana, this is LN brand of chemistry. So today we are going to discuss about the preparation of haloalkanes from alcohols chapter, from alcohols. So look at haloalkane chapter, this is the third topic, preparation of haloalkanes from alcohols. So preparation of haloalkanes from alcohols. So in that, first we are going to discuss, so what I told, haloalkanes we are taking from the alcohols, preparing from the alcohols. Alcohols R bond OH, that will be converted into R bond Cl. Alcohols can be converted into alkyl halides or haloalkanes. What type of reagents we are using for the conversion of alcohol into haloalkanes? Sir, first we are going to discuss the reagent name, that is concentrated HCl and anhydrous ZnCl2, that is the first reagent. Second reagent we are using PCl5, phosphorus pentachloride. Then third one PCl3, phosphorus trichloride. Fourth one SOCl2, thionyl chloride. These four reagents we are using for the conversion of alcohols into haloalkanes. So first one by one reagent we have to discuss in it. So first reagent, what is there? That is number one, concentration of HCl and anhydrous ZnCl2. This is, remember, the mixture of concentration HCl and anhydrous ZnCl2 is also called as Lucas reagent. What is it? Lucas reagent. Okay, Lucas reagent. How these are converting? Sir, alcohols we are taking R bond OH. If we use concentration HCl and anhydrous ZnCl2, if you take, that will be converted into R bond C. So, conversion ela jarugutundi, that we have to explain in the mechanism. Sir, observe it in the mechanism. What is happening in the mechanism? Sir, if you observe the mechanism, if you observe. So, first alcohol, yes, alcohol is there, R bond OH. Sir, we know that on the oxygen atom, two lone pair of electrons also is there. When it is reacting with anhydrous ZnCl2 like this. Once one of the lone pair of electrons attack on the ZnCl2, then what will be formed? R bond OH, then plus bond ZnCl2, like this will be formed. Clear? Yes. Then after what happened? So look at here, so in this molecule, so once bond is shifted to there, carbocation R plus, then Zn, zinc, already it contains two chlorine atoms, then OH also is there, so OH, then OH, so will be present, so then here a negative charge will be formed. So why negative charge will be formed? So then here actually when it is attached to this, here negative charge will be formed, then so automatically it will be formed. Yes, sir, R plus nothing but carbocation. So formation of carbocation is RDS step, rate determining step, that you have to discuss. Remember that. Okay. Next further step, what happens? Sir, in this how many are there? One is R plus, nothing but carbocation I told. Carbocation. Yes, carbocation is formed. Carbocation, sir, only ZnCl2 is involved in the reaction now. Then one more is there, concentration HCl. So in the concentration HCl, this can be dissociated into H plus, so plus Cl minus, right? So now H plus will be attack on it. Sorry, Cl minus will be attack on it. Cl minus will be attack on it. Then R bond Cl, alkyl halide or haloalkane will be formed. Then second one is there, ZnCl2OH. Then what is there? Even negative charge also is there. Once H plus is attack on it, then H2O. How? H plus, then OH minus H2O will be formed. Then ZnCl2 will be formed. It is act as a catalyst in this reaction. So this is the mechanism actually. So in this mechanism, sir, haloalkanes, how it will be formed, that we are discussing. So here carbocation, formation of carbocation is formed in this. This mechanism is also called as SN1 mechanism. So in the SN1 mechanism, intermediate will be formed. Intermediate is carbocation. Carbocation. Generally carbocation, how it will be? So carbon will be there. Then three other groups are there. Positive charge will be there. Then p orbital will be present above the plane and below the plane. This is one of the plane, right? So the carbocation, positive charge is there on the carbon atom. E orbital, vacant p orbital. So which is, this is the vacant p orbital. So these orbitals above the plane and below the plane will be present. Remaining three atoms which are present, which are attached to the carbon, that are present in the same plane. So now, sir, any attacking agent, any nucleophile, when it is going to attack on the carbocation, for example, here we are taking Cl minus. Cl minus is going to attack on the up or on the down like this. Sir, in case when it is attack on the up, then retention configuration, retention product will be formed. So in case when it is attack on the back side of the leaving group, then inversion configuration will be formed. Inversion product will be formed. Inversion product. For example, if you observe. Sir, one of the carbon atom attached with a phenyl group, then one is methyl group, then is H, then OH, like this will be there. Sir, Cl minus, that is anhydrous ZnCl2 only we are taking. Sir, anhydrous ZnCl2, anhydrous ZnCl2 and HCl, HCl and anhydrous ZnCl2, both, the mixture of both. That is but Lucas reagent it is. So Lucas reagent is going to attack on it. Then what happened? A retention configuration will be formed. So retention configuration and inversion configuration both will be formed, I told you. Yes. So how the retention and inversion configuration will be formed? Carbocation will be formed first. Yes, carbocation. So nucleophile, which is the nucleophile from this? Cl minus is the nucleophile. Cl minus nucleophile, upside and backside both will be formed. So in case upside will be formed, retention configuration. Upside nothing but what? Sir, ఏదైతే లీవింగ్ గ్రూప్ ఉందో లీవింగ్ గ్రూప్ ప్లేస్లోకి న్యూక్లియోఫైల్ వచ్చి అటాక్ చేసింది అంటే then we call it as retention configuration. So CH3 is there, then PH is there, then H is there, then as usual Cl is there. Then we call it as retention product. Then inversion means what? Sir, once if it is attacked, sir, all these molecules are away from each other. All these molecules are away from the attacking agent. So back side of the leaving group, it will be attack on the back side of the leaving group. So ఇది న్యూక్లియోఫైల్ అటాక్. సార్ ఏమేమి రిమైనింగ్ మాలిక్యూల్స్ ఉన్నాయో సార్ అవన్నీ కూడా సార్ దీస్ ఆర్ అవే ఫ్రమ్ దట్ పర్టిక్యులర్ న్యూక్లియోఫైల్. సో లైక్ దిస్. సో దిస్ ఈజ్ వీఆర్ కాలింగ్ ఇన్వర్షన్ కాన్ఫిగరేషన్. ఇన్వర్షన్ కాన్ఫిగరేషన్. సో రిటెన్షన్ అండ్ ఇన్వర్షన్ కాన్ఫిగరేషన్ విల్ బి క్లియర్ ఆల్ ఆఫ్ యూ? ఎస్. సో remember that first reagent we are used, that is concentration HCl and anhydrous ZnCl2. Sir, mechanism is formed like this. Sir, what is the main important point in it? Carbocation is intermediate. SN1 mechanism takes place. When SN1 mechanism and carbocation is there, retention and inversion configuration will be formed. How it will be formed? 50-50%. When 50-50% we call it is, then racemic mixture will be formed. whatever it means. That we'll discuss later in the substitution nucleophilic reactions. So clear up to there? Then one more point you have to remember that. So rate of reaction of alcohols. Rate of reaction of alcohols in this. So tertiary alcohols are, remember, rate of reaction is directly proportional to the stability of carbocation. So this carbocation means dependent. Rate of reaction is directly proportional to stability of carbocation. So tertiary alcohols CH3, CH3. Tertiary alcohols are more reactive towards this reaction. Then after secondary alcohols, secondary CH3, CH bond CH3, then OH, secondary. Then after primary CH3, then CH2, then OH. Then after methyl alcohol CH3OH, like this. Clear? So this is what tertiary, then this is what secondary, then this is what primary alcohols. This is the rate of reaction. Sir, what I told, this reagent, whatever we are using the reagent, ఏ reagent use చేస్తున్నాం ఇందులో? Concentrated HCl and ZnCl2. This reagent we are calling what? Leucos reagent. Leucos reagent దేని కోసం యూజ్ చేస్తాం? Distinguish between primary, secondary and tertiary alcohols. Primary alcohol, secondary alcohol, tertiary alcohol ని డిస్టింగ్విష్ చేయడానికి యూజ్ చేసే reagent ని మనం Leucos reagent అంటున్నాం. Sir, how can you distinguish it is? Remember that. So that is Leucos test we call. Leucos test. Leucos test దేని కోసం యూజ్ చేస్తున్నాం? So distinguish between primary, secondary and tertiary alcohols. Primary, secondary and tertiary alcohols. Sir, how can you distinguish? Sir, in case if you take tertiary alcohol is there. Tertiary alcohols are there. Tertiary alcohols, when it is react with Leucos reagent, then what will be formed? Immediate turbidity. Some members they are asking a doubt like this. Turbidity means what? Precipitate, PPT, precipitate. Precipitate will be formed immediately when tertiary alcohols if you use. So then in case if you take secondary alcohols, sir, secondary alcohols if you use with a Leucos reagent, then after 5 to 10 minutes, then PPT or turbidity will be formed. 5 to 10 minutes, after 5 to 10 minutes. Then in case if you take, sir, primary alcohols if you take, primary alcohols with Leucos reagent do not give turbidity. With Leucos reagent, LR, Leucos reagent. Understand all of you? That's what he told. Leucos reagent when we are discussing. Sir, secondary, tertiary and secondary and primary alcohols, we can distinguish. How we can distinguish? Like this using. So they will ask a question based on it in the NEET examination and JEE Mains examination. Which type of questions they are asking? So based on the Leucos reagent. Sir, which of the following alcohol will give immediate turbidity with Leucos reagent? Look at. Which of the following which of the following alcohol gives turbidity with Lucas reagent, yes. So options are given, that is OH, like this is there, then B, sir, OH, like this is there, then C, CH3 bond CH2 OH is there, then D, nota, none of the above, like this will be there. Sir, which is immediate turbidity will give? Sir, I told you tertiary alcohols gives immediate turbidity with Lucas reagent. You have to identify which is the tertiary alcohols. So where a carbon atom attached with three alkyl groups are the same or different? Three alkyl groups is there, 1, 2, 3. So tertiary, it is tertiary. Then two only alcohols are there for this carbon. So then we call it as secondary. So only one only alkyl group is there surrounded by that carbon. Then primary. So like that you have to identify tertiary alcohols gives immediate turbidity with Lucas reagent. Clear all of you? Right. So next second reagent is there, PCl5, reaction with the PCl5. So here reagents for the conversion of alcohols into haloalkanes. 4 reagents we are using. One is first Lucas reagent we are used. Then second reagent we are using PCl5. So second one we are taking, that is with PCl5. So alcohols if you take, when it is reaction with a PCl5, then R bond Cl will be formed, nothing but haloalkane. Then HCl will be formed. Then POCl3 will be formed like this. These are the byproducts. Okay, sir. Right. Sir, how does it reaction takes place? That we have to see in the mechanism. Mechanism, if you observe, the first one PCl5, when it is present in the gaseous state lo unnappudu reaction ela jarugutundi, which is reagent is present in the gaseous state. Yes, observe it. Then first we are taking R bond OH, alcohol is there. When it is reaction with PCl5, surrounded by that phosphorus, chlorine atoms are present like this. So we know that phosphorus is now electron deficient because of more electronegative atoms are attract the shared pair of electrons towards us. So already oxygen మీద 2 lone pairs of electrons ఉన్నాయి, దీన్ని డొనేట్ చేస్తున్నారు. Then once if it is attacking on it, then Cl minus will be escape out from. So ఏం eliminate అవుతుంది? Cl minus will be escape. Okay, right. Then R bond OH, then plus, then phosphorus, it is attached with the chlorine atoms with the 4 like this. Okay, up to there it is happened like this. So next, if you observe this lone pair of electrons, to satisfy the lone pair of electrons, hydrogen atom will be shipped, then sir, even H plus also will be escape out, H plus plus Cl minus both will be escape out as is HCl. Then what will be from R bond, O bond, then P, Cl, 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 then Cl like this. Clear? Yes. Sir, here one of the thing you have to observe, sir, sir, in the molecule itself, one of the chlorine act as a nucleophile. Intramolecular nucleophile we call. So this will be attack on not back side, same side will be attack on it. So once if it is attacked, this will be shift like this. This will be shift as a double bond in between them. Observe it carefully. Then what happened there? Sir, R bond Cl will be formed, right? Yes. Then POCl3 will be formed. So this product is retention product. Retention product. Retention product. Retention product. So because same side it will be attack. This mechanism we call it is SNI mechanism, intramolecular nucleophilic substitution. Intramolecular, within the molecule, one of the atom act as a nucleophile, then we call it is intramolecular nucleophile mechanism, not intermolecular, intramolecular. Okay, so like this will be happened. So this is only the gaseous state when it is present. In case solid state of, what is? Solid state of PCl5 is there. So how does reaction takes place? So that is PCl5 when it is present in the solid state. One thing you have to observe, when it is present in the solid state, PCl4 plus, then PCl6 minus, like this will be present. Cation, anion. ఇప్పుడు solid state లో ఉన్నప్పుడు. So then reaction mechanism, how does it takes place? Mechanism you have to observe. Mechanism ఎలా జరుగుతుంది? First you have to take alcohol. So alcohol తీసుకుంటాం. R bond OH, right? Plus when it is reaction with PCl4, Cl, then Cl, then Cl, then Cl, like this. So positive charge is there on it. Yes, positive charge is there. So lone pair of electrons immediately attack on it. దేనిపైన అటాక్ చేస్తుంది? ఎక్కడైతే పాజిటివ్ ఛార్జ్ ఉందో అక్కడ అటాక్ చేస్తుంది. సరే ఓకే, అటాక్ చేస్తుంది. సరే అటాక్ చేసిన వెంటనే దెన్ వాట్ విల్ బి ఫామ్? ఏం ఫామ్ అవుతుంది? సరే ఆర్ బాండ్ ఓహెచ్, దెన్ బాండ్ పి, సరే సిఎల్, దెన్ సిఎల్, దెన్ సిఎల్, దెన్ సిఎల్, పాజిటివ్ ఛార్జ్. ఎస్ ఎస్ సార్. సో నెక్స్ట్ వాట్ హ్యాపెండ్? So here hydrogen, it will be shift as a lone pair of electrons on it. It will be shift as a lone pair of electrons on it. Then what will be formed? So look at R by the loss of H plus R, then O, then PCl, then Cl, then Cl, then Cl. Next what is happening there? So PCl6 minus, nothing but what? From this molecule Cl minus act as a nucleophile, it will be attack on it. Then immediately it will be shift there. Then immediately one of the chlorine will be escape out from it. Then what happened there? Sir, R bond Cl, backside of the leaving group. So it is inversion configuration. Inversion configuration will be formed. Inversion. Here retention, here inversion will be formed. Then byproducts what will be there? Sir, POCl3 is there. Yes, POCl3. Plus one more byproduct is there. Sir, here H plus, then Cl minus, HCl will be there. So it is escape out as a Cl minus, right? H plus Cl. So like this reaction is taking place. So that you have to remember, when it is present in the solid state, different reaction. When it is present in the gaseous state, different reaction. What is that difference? Sir, once if you observe that PCl5 when it is present in the gaseous state, retention product will be formed. Mechanism also it is SNI mechanism. But here SN2 mechanism. SN2 mechanism takes place. Clear? So what is the retention and what is the inversion configuration? We are already discussed, right? So ఏంట retention configuration, inversion configuration? So ఒక ప్రోడక్ట్ తీసుకున్నాను, ఒక రియాక్టెంట్ తీసుకున్నాను, క్లోరిన్, then methyl group is there, then here benzene ring is there, then here H is there, then OH is there. దీనికి నేను PCl5 యాడ్ చేశాను. ఒక PCl5 ఏమో గ్యాసియస్ స్టేట్లో ఉంది, ఇంకొక PCl5 ఏమో సాలిడ్ స్టేట్లో ఉంది. So then reaction product when present in the gaseous state, retention configuration nothing but wherever the leaving group is there, leaving group position, nucleophile will be taken. So product we can expect CH3, then Cl, then H. So byproducts are as usual POCl3 plus HCl as usual. Then here, sir, it is retention configuration, inversion configuration. Sir, PH3, then phenyl group is there, then H is there, then here chlorine will be attacked. Remaining products are what? Yes, POCl3 is there, POCl3 is there, then plus HCl is there, right? Clear? Yes. So this is happened when PCl5 if you use. Then second one is there with PCl3. With PCl3, how does? Just noted this. Yes, done. With PCl3. So in case PCl3 if you take, so how does a reaction is going to take place? Then alcohol we are taking, yes, alcohol reaction with PCl3. Then, so remember 3 moles of alcohols if you take, R bond Cl, 3 moles of alkyl halides, then 3 moles of HCl will be formed. This is, plus one more will be formed, that is H3PO3, not HCl, H3PO3 will be formed, sorry. Sir, H3PO3 will be formed. H3PO3 will be. Sir, this reaction ela jarugutundi. Just you have to see the mechanism. Sir, mechanism lo you observe cheste clarity vastundi. Mechanism. How to observe this mechanism? First one, alcohol R bond OH we are taking. When it is reaction with PCl3, we know that even PCl3 also electron deficient. Yes, electron deficient. So lone pair of electrons are attacking on the phosphorus. Then what will be formed, sir? Then R bond O. Yes. So once if it is attacking, Cl minus will be escape out. Yes, Cl minus will be there here. Sir, Cl minus indulo nunchi eliminate ayipoyindi. Cl minus here it is there. Yes. Okay. Then if you observe the same thing, positive charge will be formed, then phosphorus is there, chlorine, then hydrogen is there like this. Yes, yes. Sir, whatever the Cl minus is eliminated in the first step, that is attacking as a nucleophile on the alkyl group in the back side. So R bond Cl will be formed, plus once if it is attacking, this is shifted as a lone pair of electrons there. Then phosphorus, already 2 chlorine atoms are there. Cl, then sir OH also is there now. OH, right. So this is inversion configuration. This mechanism also SN2 mechanism only. Inversion configuration. So remember SN2 mechanism, wherever it is there is no carbocation, there is no carbon ion. SN1 mechanism is there, carbocation will be formed definitely. So here inversion configuration is formed. Yes, inversion configuration. So first step is done. Then still reaction is taking place because here only 1 mole of alcohol is used. Then how many moles we are used in the reaction generally? So second mole of alcohol if you use R bond OH plus PClClOH. Then again lone pair of electrons are going to attack on it. Then Cl minus will be escape out. Then R bond OH plus, then phosphorus, chlorine is there, then OH is there. Again Cl minus, whatever it is escape out there, Cl minus is going to attack on the back side. Then R bond Cl will be formed plus P Cl OH, then OH. Sir, this will escape out? Yes, this will escape out. So 2 molecules we have seen. Even third molecule if you observe, so third molecule, R bond OH, phosphorus, chlorine atom is there, OH is there, then OH is there. Then once nucleophile is going to attack on the phosphorus, chlorine will be escape out. Then what will be there? R bond OH plus, then phosphorus, sir, OH, then OH. So this Cl minus మళ్ళీ న్యూక్లియోఫైల్గా అటాక్ చేసింది. దెన్ ఆర్ బాండ్ సిఎల్, దెన్ POH, OH, OH. How many OHs? Thrice. POH taken thrice. So ఈ POH taken thrice నే మనం H3PO3 అంటున్నాం. H3PO3 act as a byproduct in it. Then R bond Cls, how many are formed? So this is 1, then this is 2, then this is 3. How many moles? 3 moles are formed. Yes? Yes. So 3 moles of products are formed in this. Clear all of you? Right. So remember that in case C2H5OH, when it is reaction with PCl3, 3 moles, then 3 moles of C2H5Cl plus, what will be formed? POH taken thrice or H3PO3 will be formed. 3 moles we are using in it. So that is third reagent we are used. Then in case fourth reagent if you want to use, fourth reagent is what? It is third reagent PCl3. Fourth reagent if you use SOCl2, thionyl chloride is there. Thionyl chloride. సరే ఇక్కడ మనం అంతా కూడా హాలోక్లోరిన్స్ మాత్రమే ఇచ్చారు. PCl5 క్లోరినే, PCl3 క్లోరినే, then what first reagent? Lucas reagent if you use also, then it is formed. సరే నీకు PBr3 కావాలంటే PBr3 have to attack on it, or PI3 have to attack on it. సో రియేజెంట్ డైరెక్ట్గా తీసుకోకూడదు. రెడ్ ఫాస్ఫరస్ ప్లస్ Br2, then red phosphorus plus I2. If you take this will give PBr3 or PI3 will be formed. Then it will be involved in the reaction. For example, if you take C2H5OH, when it is reaction with red phosphorus with Br2, then what will be formed? C2H5Br plus then byproducts are as usual H3PO3 will be formed. Clear? Yes. So this is next reagent. What is there? Thionyl chloride is there. When it is reaction with a thionyl chloride, what is the thionyl chloride ma? SOCl2 is the thionyl chloride. SOCl2, thionyl chloride. So reaction if you see R bond OH, when it is reaction with SOCl2, then what will be formed? R bond Cl plus SO2 plus HCl will be formed. These are the byproducts. See, byproducts రెండిటిని అబ్జర్వ్ చేస్తే కూడా రెండు gaseous byproducts. So this method is best method for preparation of haloalkanes. Because byproducts are present in the gaseous state. Gaseous state లో ఉంటాయి కాబట్టి, so these are the byproducts are very important. So very best method it is for the preparation. So this mechanism also, it is SN2 mechanism. SN2 mechanism అనగానే సో మనకి ఏ కాన్ఫిగరేషన్ వస్తుంది? Inversion configuration will be formed. Clear? So when we are using Lucas reagent, retention and inversion, both products will be formed. If you use PCl5 in the gaseous state, only retention. Solid state, inversion configuration. Then PCl3 inversion, then SOCl2 also inversion. Clear? So if you observe the mechanism, if you observe, so what is there in the mechanism? First we are taking R bond OH alcohol, lone pair of electrons are there. SOCl2, S double bond O, then Cl, then Cl like this. Clear? Yes. So now we know that lone pair of electrons are going to attack on the sulfur. Then once if it is attacked, that will be shift there. Then resulting what will be formed? Sir, R bond OH, then positive charge, then S is there, then O minus, it will be shift there, then Cl, then Cl. Sir, H when it is shifted as a lone pair of electrons on the oxygen atom, then Cl minus, one of the Cl minus will be escape out. So it is eliminated as HCl. Yes. Then what will be formed? R bond. It is shifted there. Right. R bond O, positive charge as usual is there. So double bond is there. S, then O minus, then one of the chlorine atom. One is eliminated, one of the chlorine atom is there like this. This happened. So now, once if it is shifted there, sir, chlorine will be escape out. Actually, this chlorine, it is attacking on the back side of the leaving group. Cl minus will be attack R bond O, double bond O, S double bond O. Here positive charge is there, it will be attack on the back side of the leaving group. So back side of the leaving group, byproduct we can expect R bond Cl is inversion configuration. Yes, inversion. So remaining byproduct is what? SO2. SO2 will be formed. So once if it is attack, it will be shift there, SO2 will be formed, SO2. Clear? Understand all of you, my dear students. This is very important mechanisms you have to understand. This method is also called as Darjan's method. Darjan's method. They will ask a question. In the Darjan's method, byproducts which are formed, sir, SO2 and HCl will be formed. Clear? Yes. So in case if you use R bond OH, sir, one is Lucas reagent. If you use R bond Cl will be formed. Plus what are the byproducts, sir? HCl is the byproduct in it. Yes? Sorry. Not HCl. So not HCl. H2O is the byproduct in it. Next, in case if you take PCl5 in the solid state, sir, R bond Cl will be formed. Byproducts are POCl3 plus HCl will be formed. Then PCl5, when it is present in the gaseous state, then R bond Cl will be formed, POCl3, then plus HCl will be formed. So then all are same, but what happened there? Here it is retention configuration. Retention product. Here inversion product. So this mechanism is SNI mechanism. This mechanism is SN1 mechanism. This mechanism is SN2 mechanism. Next one more is there. Sir, in case if you use SOCl2, thionyl chloride, then one more PCl3 if you take first, PCl3 if you take, then R bond Cl plus H3PO3 will be formed. So here 3 moles of products will be formed if you use 3 moles of. Then last one SOCl2, even this is R bond Cl will be formed plus SO2 plus HCl will be formed like this, right? So even these two also SN2 mechanism, wherever the SN2 mechanism is there, inversion configuration will be formed. Understand? Thank you, my dear students. These are the preparation of haloalkanes from the alcohol chapter. Next topic we will discuss properties.